Yeah, predicting user behavior for marketing efforts is a big trend, and sometimes the strategies on how to do that are born out of pure necessity. Our next speaker works for the Russian company Edadeal, which is comparable to the German Kaufda. As their major metric is retention rate, they sometimes have issues measuring that or to wait for the numbers because it takes sometimes up to 2 weeks for them. And that's a bit like riding a car blindfolded, so they never knew how to adapt their marketing strategies. Therefore, Marat and his team developed an algorithm based on machine learning that helps them to predict the user behavior more accurately. And how exactly that works and how he uses that, he's now going to explain himself. Please give it up for Marat Zhanabekov. Hello.
Do you have a clicker? Oh, thank you. Okay. Yeah, hi folks. My name is Marat. I'm working as a growth hacker to the app called Edadeal. And today I'm going to show you our case about predictive marketing. So before I start, I'd like to highlight some information about our app. So yeah, it's basically like Kaufdas. We are aggregating discounts and best offers in the nearby shops. I know supermarkets, cosmetics stores, zoo stores, etc. Also, we provide some coupons and loyalty programs to our users, and some useful features like shopping lists and stars on the map, for instance. The important note is that our app is not about selling something or deliver something directly to the user. We're just aggregating the content and provide it to our customers. So Edadeal runs about 3 years, and first 2 of them we've shown steady growth. Here is our weekly active users chart. But at some point, something went wrong. Does anyone know what is wrong on that chart? Except this is in Russian. Anyone? No? OK, I'll show you. Well, at this point, something went wrong. And during that period, we just stopped growing. And that was a real issue for us. And we started investigating it, why our growth stopped. Here are the reasons. The main reason is that CPI increased rapidly and our marketing budgets did not. And that's the issue. So the flow of new users couldn't compensate the churn of the old ones. But that's not the core reason. And we dig deeper and found that it became too pricey and time-consuming to test new hypotheses, to find new creatives, new videos, ad sets, audiences, targetings. But that's not the core reason too. And the idea is that our app is about the content. We don't like Reddit, and users just scroll and scroll and scroll and do nothing more. So our only metric that matters was retention rate of the first week. So consequently, we should wait, well, at least 14 days to find out if the traffic is good or not, and that was really painful. We assume that maybe there is some magic event that happens earlier and correlates with the retention rate, so we don't have to wait 14 days. And we build a simple funnel for our app. As you can see, about 90% of our users completes the tutorial, and about 80% of them did something else except tutorial, but only 45% returned on the first week. So there is a massive drop from any other actions to return on the first week boxes, and the tutorial could not be this quality metric. And if this quality metric even exists, it is somewhere inside this box. So OK, the first natural thing you could do is let's find the time range where this magic event could happen, and we built a histogram which showed the sessions count in 30 days and the number of devices with such sessions count. And as you can see, a lot of devices have exactly 1 session in 30 days. So naturally, that could mean that a lot of people well, just downloaded our app, skipped the onboarding, interacted with our app, and found that that is not their case. They don't like finding discounts. Their shop behavior is different. This app is not for them, and they just delete it. That's okay. You always have such cohort of users, but our main goal was to reduce their share in our paid traffic. So the whole idea of this slide is that if something happens, it happens on the first session. It is the most valuable time of interaction between user and your app. So here is the, yeah, it looks pretty messy, but it is a customer journey map. So the vertices of this graph are the screen appear events, and the edges are conversions. And we've tried to find some successful ways from initial state to artificial return appear event. And here is the one of these passes. Yeah, looks pretty good. That could solve our problem, but it did not, because only less than 10% of our users follow that path. So there are a lot of successful scenarios for users into our app, and that was the challenge. So as you can see, we have pretty good analytics inside our app, and we have more than 500 unique in-app events, and each of these events have, I don't know, about 10, maybe 15 custom in-app event parameters on one hand. But on the other hand, we have a lot of successful user scenarios. When you have a lot of stuff, when you have a lot of data, just use big data. That works simple, and we've developed an internal service which gets the input, the first session logs, first session sequence of events for each user, and somehow scores the likelihood for each new user to the good users. I don't know, I'm not sure I want to share with you how we exactly did it, but because it's to be honest, it's boring. I'd like to show you some problems we faced with, because if you'd like to solve this churn prediction problem, you'll face it too. So let's begin the problem number one about your data consistency, necessity, and sufficiency. And this is scary words, but it's pretty simple. Here are the instance of sample of event and its custom parameters, and there is a lot of garbage. As you can see, sometimes just empty strings are collected, and that's pretty bad. They just consume the space on the hard drive. For instance, you can see compilation UUID parameters and compilation name parameters, which are the same. Just UUID, the ID for compilation name instance, and it's just unnecessary to store the whole UUID. It consumes the space on hard drives too. And my favorite is about item ID parameter, because on the Android it was stored as a string, and on iOS app it was stored as an integer. So when I've made a grouping, I've received 2 times more data than I assumed, and that was really mind-blowing. And to find this bug, I've spent 2 weeks, and I've spent more than 4 weeks to make a release, and I've waited until our users will update our app and the clean data was received. So my advice is just do your analytics good as soon as you can. So you'll store the cleansed data pretty fast. So the next problem is about dataset cleansing. A lot of people think that to be big data scientist is pretty good because you're just training models and it's fun, you're working with neural networks. That's bullshit. 80% of data scientist's job is about dataset cleansing again and again and again, and that's a pretty routine job. It consists, for this particular problem, from 3 things. So the first one, you have to reduce the number of noisy features. If you solve previous problem good, that won't be a problem for you. There are some techniques that you could do to reduce the number of noisy features automatically. Technically, it is singular value decomposition and PCA. I'm sure you know what is it. So the second problem is you need to get rid of compromised users, because incentivized users or bots could confuse your model because they could behave as bad ones, but they could be marked as good ones. And you have to remove them from your training set. And the last but not the least problem is about balancing your data set. Because if you want to predict, paying users, average conversion is about 3%. So for a model, it's cheaper to answer that each user won't buy something, because the accuracy in that case would be 97%. So you have to balance the data set. There are some techniques how to do it, but the best one is to have a lot of data. So solve problem number one as soon as possible, to have a lot of data. That's it. The problem number three is pretty common, but okay, let's just dive into it. Your app changes in time. For instance, there is our app like 3 years ago, and here we can see our app like now. And user interacts with your app differently since it changes. So you just can't train your model once and its accuracy will fall over time since your app changes. So you always have to train model again and again and again, and challenge your new models and old ones to choose the best. And the problem number four, which actually doesn't exist, a lot of people ask me which algorithm, machine learning algorithm, they should use. There are two different approaches in solving churn prediction problem. So the first one is called vector-based approach, when you represent your user as a list of some features. And the order of features in that list doesn't matter. The advantage of this approach is that you have an interpretable features, and you can see that, I don't know, feature if user ordered in last 7 days is really impactful, and some other features are not. But the disadvantage of this approach is that you have to craft these features manually. For instance, in my production model, I have more than 2,000 features, and that was really painful to generate them. The other approach is based on the sequences. So you have event sequence, and you can just use this sequence as an input. So generally, in this approach, the main strategy is using recurrent neural networks. So you'll have a hidden state which changes each time you send their event. And when your event's ended, you just cast your hidden state to one number, which is the score. So the main idea is that doesn't matter which approach you'll choose, because the performance, both of them are pretty equal. I've tested it. So let's take a look on the marketing side, how it looks when you implement, well, this scoring for churn. You'll have a traffic source. So user clicks on the banner and goes through the tracker. It is our custom tracker. To the App Store and downloads your app. After that, the user will open it and generate some events by interacting with your app, obviously. With some frequency, we extract events to our data warehouse and send the row sequence to our Blackbox, which scores each new user, and send these scores to our tracker. And tracker sends postbacks to our traffic source. So basically, it's common cost per action model. I think this is pretty simple for you. How it looks on production. Hope you remember when I said you have to challenge your model again and again, and it's fair even if you train your first model. So here is the deal. We made a split test with one traffic source and a set of creatives. We made two types of campaigns. The first one was old-fashioned way, when we waited 14 days until any optimizations. And the orange one is where we used predictions to optimize our campaigns. And this graph is a retention rate of the first week in Dynamics. So on the x-axis are weeks, and on the y-axis are retention rate. And as you can see, the orange one won, I guess, so that was pretty fair. The other plot is about long run. It is 40 weeks of life of our service. So the green line is retention rate in Dynamics, and the blue line is the amount of installs. Somewhere here we started our campaigns, and that was pretty good. Our retention rate was growing. But at some point, our service had a downtime for a week. Our affiliates noticed it and sent us a lot of bad traffic. Well, we punished them and started fine-tuning our models, so there is unstable retention rate. And at some point, we achieved the stability, and that was good. Hope you remember that plot of weekly active users that I showed you. And here is the extension, well, where we implemented our predictive approach. Hope you got any idea what I was talking about. And if you want to read something more about it, I suggest you some stuff to read. First is the case of Yandex Data Factory and World of Tanks. Pretty good case where guys tried to solve churn prediction problem like 4 years ago, and it's pretty awesome. Highly recommended to read. Also, does anyone here works in Zalando? Nope, nobody? Okay, these guys are really good at predictive marketing. They know a lot about deep learning, about machine learning. So here is the link to one of their article in their blog. But the whole blog is pretty cool, so highly recommended to read. And the last, but not the least, the case of Jelly Splash. It's match 3 game. They had some experiments with churn prediction problem, and highly recommended to read too. Okay, I think my presentation came to its end, and if you have any questions, you can catch me like here or just type me on Telegram. Thank you.